Good morning, class. Good evening, good afternoon, good evening. Salam alaikum wa rahmatullah. It depends on from where you are joining the program. And now we have students from US, from Morocco, from India, from Kuwait, and from Dubai, and from other part of the world. So this is again a continuation of yesterday's session where we talked about an introduction to machine learning, and that's what we covered yesterday. We learned about the concept of machine learning compared to the concept of programming. What is machine learning versus programming using an example, child example, or a human example. And we as a human, we make decisions every day. We got thousands of decisions. Either you like it or you don't. We make decisions every day. What to eat, when to go to bed, what time you wake up, what time, who's to call, whom to call, what is your priority, what to do, where to drive, where to play. So we make decisions every single day. Some decisions, they are as simple, as easy, as very, very simple. Some of them, they are complicated. Some of them, they are very simple. Some of them, they are game changer. Okay, so in your opinion, if I were to ask you, how do you make decisions? How do we make decisions? Let's brainstorm a little bit. Let's brainstorm. How do we make decisions? And I'm going to
based
start.
on
We make a
based
decisions
on
based on information. You've been working so hard for the last 3 years, then you decided to take a vacation, take your family to Africa. Or you have Africa, or you have Morocco, or you have India, for example. You have Morocco and you have India. Of course, you are not going to go to Morocco like that. You have to collect some information about Morocco. How safe is Morocco? How cheap? The lodging. You look into the food. Better places to go to. And you do the same for India. You look into you first check the safety, how safe it is to take your family to India, and also you look into other places, other things like you look into how cheap, how much money you are going to need, where do you need to go, is there a way to stay now, where do you need to stay, and you're looking for a lot of things. So you are making a decision based on information you collected. Then finally, you make a decision either to go to Morocco for 2 weeks or go to India. So, so we make decisions based on information, or we are information-based decision making. This is one way to make decisions in our daily life. Another method of making decisions is comparing. It's similar to the information, but we are going to compare three things. Like, for example, last year I took my family to Canada. It was beautiful. Beautiful, we enjoyed the stay, we enjoyed the weather, we enjoyed the prices. It's safe, and we really enjoyed it. We want to go, but not to Canada. And now we have Morocco and we have India. So we are going to compare Morocco and India to Canada. Which country is closer to Canada in terms of safety, in terms of prices, places to stay, food, culture, whatever. And we are looking into the similarities and dissimilarities, and this is called similarity-based decision or similarity-based learning. We are making decisions based on what we learned in comparing two programs or two countries to the country that we are familiar with. The first one, We are making the decisions through what we have learned from the information gained, information collected about these two countries, Morocco and India. The third way of making decisions is having some fact numbers. Again, you've been working for hard for many years. You have enough money now to take your family to a vacation, and you have Morocco, you have India. And guess what? Randomly, you decide to go to Morocco, and in the last minute, you heard that there is a probability it's going to snow in Morocco. Then, of course, you are not going to be, unless you are drunk and full, then you are going to make a decision to take your family to Morocco. So we are going to go to India. So we are making decisions based on some facts, some probabilities, some numbers, so quantitative data. Then we are making decisions based on the past decisions. I went last year, I took my family to Canada. It was horrible. I did not enjoy it. The food was horrible. The weather was hot, and the prices that are very, very, everything is very expensive. And I took my family and I regret. So, do you think I'm going to make a decision? Now I have money, I'm going to take my family. Do you think I'm going to take my family to Canada? No, I learned from my past mistakes, my past experience, my past errors. These are some of the ways we are making decisions in our daily life. Okay? So now we want to build machine learning. We want to build systems that mimic the way we behave. We want to build machine learning that make decisions based on some information they collected from the data. We want to build machine learning that make decision based on comparing two elements of your data. We want to build machine learning that make decision based on some probability. And we want to make a machine learning that make decision based on the trial, error and trial. And of course, there are other type of ways of making decisions. And of course, we have probably machine learning that could mimic the way those decisions are made. Any questions, concerns, please? Any
I'm good
questions?
with the concept.
Everybody, I know we have 23 students in the room. Any question, concern, please, on what we are trying to do?
Oh,
Okay, so in terms of information-based learning, we have many algorithms. One of them is called decision tree. We got random forest. We got all algorithms that are built on the top of decision tree, like bagging and boosting, gradient boosting, ADA boost, XGBoost. They are all based on decision tree. So this decision tree is making decisions the way we make decisions in our life based on information gained and information collected. We got similarity algorithms. That algorithms they are using similarities and dissimilarities between elements of the data. And how do we calculate these similarities is using the distance. There are many distances used in this area. I'm going to name few: Euclidean distance, Mahalanobis distance, Manhattan distance, Chevy distance, cosine distance. There are other distances that we can use to find out how similar two things and how dissimilar they are. And we got some supervised learning algorithms like nearest neighbor, and unsupervised learning like K means algorithms. They are all using similarity-based learning. Probability-based learning, of course, they are using probability. They're extracting probability from the elements of the data, and based on those probabilities, they make a decisions. I'm going to name few. We get naive based algorithm is using probability. We got logistic regression. It does use probability based learning. Error based learning is a model that tries, then try again, then try again, and keep improving its accuracy through trying many times. And I'm going to name few if I'm right. So simple linear regression, multilinear regression, they are using the error-based. Today we are going to concentrate on decision tree and information-based learning. Unfortunately, we won't have time to go through all of this. Yeah. So yes, we are going to start with supervised learning, and yesterday we talked about the difference between supervised learning and supervised learning. The difference between them is a given target variable or absence of target variable. So supervised learning, we have a target variable. Unsupervised learning, no target variable. Then within supervised learning, it depends on the type of the target variable. If it's a binary target variable or trinary or multi-class or nominal, it is going to be classification. And in classification, we are going to do decision tree or naive Bayes, logistic regression, support vector machine, kernel-like support vector machine, k-nearest neighbor, ensemble method, random forest, Bayesian boosting, gradient boosting, ADA boost, light boost, XG boost. They all can work for any classification problem. Any classification problem where you have a target variable that you're trying to investigate, and the type of that target variable is either nominal, binary, trinary, multi-class, and nominal. Okay, if your target variable is none of these and it's a continuous, then we are going to use regression. And in regression, we could do simple linear, then simple linear is one variable and one target variable. Multiple linear is many variables and a target variable. Polynomial is a short version of simple linear regression, which is used when simple linear is not linear, is a non-linear. We are going to use polynomial. Lasso, ridge, elastic net, they are versions of multiple linear regression. They are used to penalize features that don't add any value to the analysis. And decision tree, support vector machine. These are some of the algorithms that work for both regression and classification. And one of them is decision tree. Support vector machine, random forest, Bayesian, gradient boosting, ADA boost, XG boost. They all work for both classification and regression. So today we are going to talk about the decision tree. This is our first model. So we got the data. Yeah, the data is there. It's ready to go. Yeah, we got the data. Okay, and now the way we are going to learn from this data, as I mentioned yesterday, we are going to split this data into 80%. So it's called historical data. Whatever value, whatever number that you have is called historical data. And the best ready historical data is a data that has more rows and less columns. Less columns and enough rows, millions of rows and a couple of hundred of columns. Otherwise, you need to reduce the dimensionality of your data. Why? You might ask, why do we need to reduce the dimensionality of the data? Many reasons, including number one, the more dimensional data they have, the slowest calculation you are going to get. This machine learning is all math, and they are going to process this data, which is going to be numbers, heavily a back end. So the more features that you have, the more combination these algorithms are going to try. So it is going to slow down the process. And if your management needs an instant answer or instant prediction, using high dimensional data is going to take a while before you get the answer to the business. That's number two. Number one. Number two, high dimensional data will definitely it's going to be hard with high dimensional data to make to visualize your data. You could visualize two features, you could visualize three together, four together, five together, but 200, it is absolutely no way you can visualize all these 200 at the same time. And even if you are able to visualize your 200 columns, it is going to be so hard to explain what's going on. It's going to be so hard to interpret the end result. And the business hired you to make things simple. Now you are making things complicated. Number three, why do we need to reduce the dimensionality? Is because there is something called, it's called curse of dimensionality. Please search it up. Curse of dimensionality. I am not going to explain it. I know I can, but we don't have time. So we have some reasons, some logics why we need to reduce the dimensionality. I repeat, it's going to speed the process. It's going to be hard to interpret and visualize. It might create what we call cursive dimensionality. And if you have a cursive dimensional data, definitely your end result is going to be biased. So we are going to take this historical data, and we are going to split it randomly into 80% and 20%. Random is going to be 80%. We are going to shuffle it and split randomly into 80%, 20%. And the 80%.
One big question here before you proceed further.
Yes, ma'am.
So, is there any mandatory rule, a strict rule that we need to split into 80-20, or can we do 70-30? Like how it works?
Doesn't really matter, but the training. So the 80% is called training set. The 20% is called testing set. The training set.
It doesn't matter how we split 70-30 or 80-20.
No, it matters. It matters. Training set has to be larger than testing set. That's all we care. You could do 80-20, 90-10, 70-30, but don't go below 70.
Oh, okay.
Okay? And this is not the only way of learning from historical data. There are other techniques. Unfortunately, we are not going to cover them, but we are going to focus only one. So we are going to do 70-80-20 or 70-30 or 85-25 or 90-10. I don't recommend it, but the most common split is 80 and 20. Okay, 80% is called training set. This is the set. This is the part of the data we are going to try to learn a pattern. We are going to try to learn the hidden mathematical patterns in the data. Using what? Using machine learning. What machine learning we could use? Machine learning based on information-based machine learning. We could use similarity-based machine learning. We could use probability-based machine learning. We could use error-based machine learning. We could use many machine learning. And what is machine learning? Is simply a mathematical algorithm. It's a math. It's all math. It does a lot of computation out there, computation of the numerical variable of your data. And once we apply machine learning, then we are going to extract a pattern. A pattern is simply a statistical finding. It's a function. Yeah, we are going to, for example, find that age plus 10-year plus salary is high age, low salary, and would simply make someone commit a fraud. We find that using statistically, that is what we found in the data. So we are going to train our model on 80%, and this model will produce something, but we have no idea how good that something is. No idea. It could be the right thing, could be the bad things. We don't know yet. So we are going to take this something and let's call it for now pattern. But mathematically speaking, it's a function. But we are going to use the layman term that is a pattern. So we are going to take this pattern that was discovered when we trained the model on 80%. We are going to train many models. 2 here, 3 here, 2 here, and 1. At the end, we got 2 and 4, probably 8 models. 8 models, different models. And these models, they learn differently. Some of them, they are learning using similarity based. Some of them, they are learning error based, probability based, information based. They are different learning. And let me stop here for a second, and I promise to come back to this. This is most of the students now taking this program. This is the attendees. And I'm training you on a BBDS data science program. I'm training you, all of you. You are taking this program. And I want you guys, I want only one person to represent me next year, let's say, in Dubai conference. So I'm going to train this, all of you, on this program, and I want you to represent me. Represent. What is the best? What do you think would be the best representer? What would be the best? What would be the optimal representer?
Presentation skills and knowledge of the subject matter.
It's someone who copies me, right?
Yeah.
Who's very
Right.
close.
Not exactly copying, like they should know what they are talking about.
But it's very close to Momidwani. Very close to me.
Yep.
I am not.
Closest. It may not be exactly like you.
Yeah, I don't want you to be like me, but very close to me. The way I explain
Yes.
the concepts, the way I joke around, the way I make, I create stories. I want you to make Dubai conference happy.
Yeah.
So that is what we're trying to do. And all of you guys, you are trying to learn, but the way you learn is different. I know, for example, Hina is very fast. For example, Fuzia very slow. Fatima is mathematical mindset. Corina, she learns by heart. Zam is learn very learn is multitask. All of you guys, you have the same brain. The same brain, the same elements of the body, with some exception, but the ability to learn is different, right?
It's correct.
So I'm gonna put you under training, and I'm going to test you. I'm going to put you into training, and before I send you to Dubai, I'm going to send only one person, and that one person, all of you will have the same chance, the same high quality training program, the same length. It is going to be from start date to end date. So we want to give everybody the chance, equal chance. And now, once at the end of the program, I'm going to test you. Then I'm going to pick only one person who is going to represent me in Dubai conference. I want this person to train or to teach a class. To why I teach it here in US. I don't have time to go there. I have another conference in South Africa that I want to go to, but I don't want to miss this one. So I'm going to train someone out of these 23 students, and I'm going to test you guys to represent me. I am not looking for someone who's going to copy me 100%. Why? This is impossible. I want someone to be as closer to me as possible. And these are models. These are models. All gonna learn, but they learn different way. They are too different in the way they are learning. Different. And we are gonna train you on the same subject, the same environment, the same platform, the same programming language, the same data. But the way you learn is something that is the way you are designed. This the way you are created. So this is decision tree. This is a random forest. This is a logistic regression, naive Bayes. This is separate vector machine. This is INN, KNN, and this is all type of models. So in real life, we are going to train everybody. I cannot straight say, okay, Noreen, I'm going to train you. I'm going to train you and take you to Dubai. This is not going to work. Before we find if Noreen is the best representer, we got to try everybody. We got to try as much models as possible, and we are going to train. The everybody probably on 90% of the program, and we are going to keep 10% of the program to see how you guys are going to do, how you are going to perform. So we are going to train you on 90%. We are going to test you on 10%. And of course, we are going to get one. Sometimes we are going to see that we have 4 students. They are a very perfect, very good match. They will represent you perfectly. I mean, the client, they are going to be happy, but you have to choose only one of them. You guys have any questions, concerns about this?
I'm good.
Anyone else? I know we have more than 23 students. I want to hear you guys. Z, Vina, Tuama, Sayed, Shamsul. Please speak out.
No for me.
Okay, folks. So that is an analogy of how these models are learning from historical data. So we are going to split the data into 80% and the 20%. And as I said, this is not the only way of learning, but we are going to split. And that the 80% is called training set, the 20% called testing set. We are going to apply machine learning. This is you guys. This is all of you, a group. We are going to give you this data and I want you to learn something. So give me what you learned. And what you have learned, I have no idea if it's good or bad. So what we need to do, whatever you learned, we have to test it in 20%. And the way it works, so let's take a look into our data one more time. So this is our data, but this is not the latest version. This is original data. Okay, this is original data, and this is target variable. Okay, so we got a target variable. Okay, let's assume, for now, let's assume this is all our data that we have, just for the train purpose. We are going to assume this is all the data that we have. Okay, this is all the data that we have. So randomly, we are going to split the data into 80%, 20%. This is randomly, random split. Okay. Now we are going to train the data on 80. This is 80%, and this 80% is called training set. We are going to train this data, and in this data we have two type of variables. We have blue. The blue is called X. It's also called input. It's also called independent variables. Has many names. The green is called target variable. It's called Y. It's called also output. It's called outcome. It's called a label. Sometimes it's called a class. But we are going to use two terms, X. We are going to use X and Y for now. Okay, we are going to use X and Y. So we are going to train a model on this 80% using a function called fit. Fit. And we are going to fit what? We are going to fit the X, comma, Y. What is X? All the blue features. There's going to be X1, X2, X3, X4, Xn, and the Y is going to have only one. So when we fit means train. When we fit our model into 80% X and Y, we are going to learn a pattern. And how good? No idea yet. Now we are going to test this pattern into this data. And in this data, we are going to hide this. We are going to hide the Y. We are going to hide the Y. And to test the patterns on this 20%, now this is 20%. It's called test. So we use the fit to learn, then we are going to use predict function to test. And the predict, we are going to give it only the predict. We are going to pass only to it. What do you think we are going to pass to it? What variable that we need to pass to the predict?
X.
X. We are not going to show it the Y. We are going to hide the Y. And what is going to happen? What is going to happen? This predict is going to create one variable. It's called, this one variable is called X hat. I'm sorry, Y hat. Y hat or a predict. And the value, so the model is going to come up with its own target variable. It's going to be 0, 1 1 0 0 1 1 0 0 1 0, etc. And now we are going to compare the predicted target variable with the actual target variable to see how accurate the model was. Accuracy is going to be 100%. The more closer to 100%, the better. Do you guys understand the concept?
Yes, ma'am.
Anyone, please? Any doubt, any concerns, please speak out. Fozia, Fatima, Corina, Azam,
I have it.
Shami, are you guys clear?
Yes.
Okay, so now let's practice. So we are going to do
Has been a question. So this is 100% based on the function and algorithm, right? So we will not have any what's called a confidence level here. The predict is really going to be much accurate here.
I'm not sure if I understand your question. Can you please repeat?
Yeah. So the predict, like when we pass the x with the data here, right? The y cap, the y cap is really going to match that algorithm, and that's really going to be 100% accurate.
No. So when we train the model, we train the model on all 80% x and y. X and y. So this trained model, it is going to try to find the mathematical relationship between x and y in terms of a function called y
Mhm.
equal a function of x1, comma, x2, comma, x3, comma,
Mhm.
xn. So this is the function that works for all your 80%.
Okay.
How good this mathematical function that you see here is called patterns. So now we want to test this mathematical function on a data on 20%. But we are going to hide this target variable from this function. We are going to give it only x. And this function, using the predict function. Yeah, predict function, we are going to apply this function here using the predict function on the 20% x only. And this predict, what it does, it is going to create its own, it's going to create a new column. And a new column is called the predicted target variable, and the value of that column is going to be either 0 or 1. So for example, this one, it was a 0,
Mhm.
and the model predicted as 0. Is the model doing good or bad in this one case? So this is you. This is you. Your claim was legitimate. Okay?
Okay.
So then we feed all your data to this function, but we did not tell it if it's legitimate or fraudulent. We want to see what is going to come up with. Then the
Okay.
model says, I think you are legitimate. So is the model doing a good job, and how accurate the model is in your case, in this one case? You tell me. Can anyone help?
Yes, please.
Okay, what is the accuracy for prediction on this one case?
That's 100%, right? So
100%
it is
correct.
yes.
We got 0 and 0.
Yep.
Second case, let's say this is Fauzia. Fauzia, she had a legitimate claim, but we feed the Fauzia's information on this function, and we did not tell it if what type of case she had. We did not tell it if it was legitimate or fraudulent. And what
Mhm.
is this function predicted? Fauzia is 1. So is this a good or bad?
It's bad.
It's 100%. The first one is 100% correct. The second one is 100% wrong.
Wrong. Yeah.
The model made one mistake now. Then we are going to do the second, the third, the fourth, and at the end, we are out of this 20%. We are going to calculate how many mistakes this model did on a data that we already know. So if you are happy, of course, it's going to make a mistake.
So one question here
Yeah,
more.
please hold on.
So
yeah, please hold on.
if you want to proceed with the model,
please hold on.
Oh, okay.
Thank you. I'll give you a chance to ask your questions.
Sure.
Okay, so at the end, we are going to compare the y hat to the y. And let's say that we got 90% of cases correct and 10% of cases incorrect. If you are happy with this accuracy, then we are going to put this algorithm into production.
So that 10% can be sent to the supervised decision making, right? Like instead of taking a decision from machine learning, 90% is like taken care by the system or the machine learning.
No,
10% can be.
No, brother. 90% your model is accurate.
Okay.
10% is the model could make a mistake. 90% your child learns the candle, patterns from the candles, and 90% he's not going to touch the burner gas. 10% he's not going to touch the toy.
Okay, got it.
This is all related to algorithm. So if you are happy, this is very high. Our model predicts everybody in the past 90%. So tomorrow, let's say that we have Shahid. Tomorrow, Monday, Shahid called us. I said, hey, I have a claim that I want to report. And we really don't have a budget. We don't have a resource to investigate this claim. We are going to feed the information of Shahid into this formula. This is artificial intelligence that we already know it's 90% accurate, 10% is going to make an error. We are going to feed Shahid information to this formula, and we are going to get a 0 or 1. We are going to get one of them. If it's 0, it simply means we are 90% accurate that it's 0. But there is a 10% chance we could be wrong. If it's 1, if the model says it's 1, we are 90% sure it's 1, but there is 10% we could be wrong.
Yeah, I got it. Thank you.
Okay, you are welcome. Okay, I know Parvati, you had a question?
Yeah. My question here is like in our example that we have just discussed, the accuracy of the model is 90%. So usually what would be the accuracy percentage of the model, like that we know the model is accurate? Is there any like specific range?
We are going to talk about that shortly.
Oh, okay.
Okay, but I am not looking, again, I am not looking for someone to copy me 100%. Yeah, so let's say that Zorin is the best. Zorin can represent me 90%, but always going to be 10%. She might miss up something. No, so this is the models. If you got a model that is 100% accurate, you are doing something wrong.
Yes, I agree with that. It should
wrong.
not be 100% accurate.
Yeah. I mean, the 100% is the goal, but it should not be 100%.
Okay.
Okay, so now let's practice, and I will come to your question. What is the base?
No problem.
Okay, and the answer to your question, I'm going to give you an example. And so let's assume that I'm talking about the brother here. You are married, okay, and your wife has been pregnant for 9 times. 9 times. The first time it's a baby boy. The second time, baby boy. The third, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth is baby boy. Now she is pregnant again. What do you think would be what would be what do you call it? What would be the type of forgot the name?
Probability of
What
Total the chances.
yeah, what would be the
What might be the chances?
yeah, what do you think would be the type or of the new expected newcomer?
Baby boy.
It is going to be a boy. If you were to guess, it is going to be a boy. Why? Because we have boys in the history. If we got, for example, if we got yeah, you got 1, 2, 3, 4, 5, 6, 7, and 8. We got girl, girl, boy, 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 girl, girl, and boy. So you got 1, 2, 3, 4. We got 4 boys. 1, 2. We got 5 girls. And now your wife is pregnant. What would be, if you were to guess, just make a guess, what would be the outcome?
sounds like a boy again.
It is going to be no.
The pattern.
It's going to be a pattern. Is going to be a girl. Is a pattern. It's going to be a girl.
Go.
So this is your base. This is your base. We are going to go to historical data and find out what is the pattern. If we were to guess, and that is what we are going to look into shortly. So we are going to go to Python. Okay, Python. We are going to go supervised learning, supervised learning classification. We are going to do decision tree. Okay. Good. So we are going to import the libraries. Let me zoom out a little bit so you can see the fonts. Here we go. Importing the libraries. Please let's give it a minute. It's still thinking. You got the star in there. It simply means still thinking. But it should not be slow. It should not be this slow. Let me kill the kernel one more time. There we go. I'm gonna kill it again. Okay, now let's try. So we got the libraries imported. NumPy, Matplotlib, Pandas, Seaborn. Set the maximum columns to read. Option display max column 70. Options display max. And now we are going to read version number 4. If you guys remember, this is the last version. And it's all this version now, it's all numeric. So we removed the outliers, we removed missing values, we transformed categorical to numeric, we dealt with the skewness, we did all the type of problems that we found when we did the data exploring. Okay, and we are going to remove this. Now let's take a look into our target variable. Our target variable, this is historical data. In this historical data, how many claims that we have? How many claims that we have? You guys remember?
1,000.
Got 1,000. And out of this 1,000, we got 753. They are legitimate claims. And we got 2, 47 fraudulent. Okay, Parvati, if you call us today to
Mm-hmm.
report a claim, God forbid, I don't wish this to anyone, but let's say that you call to report a claim. You are our client, then you call. If I were to guess,
Mm-hmm.
what would be my guess?
Like based on the pattern, like you might think it's a legitimate claim.
Yes, that's it. Okay, so we got 75%. I would say Parvati is 75% legitimate. But I could be wrong. How much?
25%.
25%. I could be wrong.
That's correct.
Okay, now I brought you in as a data scientist and I want you to improve this. This is called Bayes model. Bayes model, or it's called dummy model. So whatever model we are going to build in the future, it has to be better than Bayes model. And Bayes model is simply we are guessing.
Okay.
Okay, Makami and Parvati, please mute yourself. Corina, please mute yourself. Tawama, please mute yourself, sir. Yeah, please mute yourself. You are sick. Thank you, sir. So whatever model, now without machine learning, I can guess that Parvati's case is 75% legitimate and 25% I could be wrong. This is too much, 25% error. There is too much. There is a huge, there is a chance I could be wrong, and I want to minimize. I want to minimize the chance of being right. I'm sorry, maximize the chance of being right and minimize the error. Right? So that is the best model. Okay, 75% historical data is 75% is legitimate, is 0, and 25% is 1. Okay, so now for machine learning, especially if you are using scikit-learn, few things that happen. Number one, we need to tell the model what is X and what is Y. We need to identify X and Y. When we are feeding all this data into the model, it does not know which is which. So we are going to tell it, hey, our blue are our X's and the green is the Y. So now the model knows what to investigate. So we have to identify X and Y. Okay, number two, we need to split the data into two parts. 80%, and it's called training set, and 20%, and it's called testing set. Number three, we are going to import the model. We are going to import the model. Yeah, we are going to import a model. Number four, we are going to establish the connection with the model. It's called initiate or start, or simply start the model engine. Number five, we are going to train the model. We are going to train the model on the 80%. and X and Y. And X is capital because we have more than X's. Y is lowercase because it's only one X. And number 6, using the fit function. Number 6, we are going to test the model on the 20% X only. We need to hide the Y from the model to see how the model is acting. And we'll be using the predict function. Number 7, or 6.1, predict function will create a new column called predicted target variable, or simply Y hat. Okay, number 7, we are going to compare, we are going to calculate the accuracy of the model by comparing the actual target variable brackets Y with or to the predicted target variable brackets Y hat. Number 8, we are going to optimize the model performance. Number 9, we are going to automate the model in production environment. Okay, these are the steps. And this is, anyone can do this. Anyone, trust me, can do this. I'm going to show you something. Look for Midwani, and I'm looking for Midwani. Got a lot of videos in there. Some of them I don't know. Where is it? Yeah, let me stop here. This is my son.
Hello guys, Assalamu alaikum. My name is Amir Nurdwani. I am 9 years old. Today I am sharing with you guys my first ever Python program using Jupyter Notebook.
Is even my child, he could do this. He could do this. This is easy. Now, machine learning is an easy task. Very easy. Regardless of your background, you still can do this. Very easy. The hardest part is preparing the data to get to this part. Preparing the data, my son cannot do it. Or gathering the business problem requirement. So machine learning, I thought when I first, learning data science that machine learning is the hardest part, but it turns out to be the a piece of cake. So you need to identify X and Y, you need to split your data, you need to import the algorithm, you need to establish the connection or start the engine, you need to train, you need to test, you need to compare, you need to optimize, you need to automate. All this is an easy task. So let's do that. Okay, now we are going to identify X and Y. What is X? Everything except, but please drop this animal here. So everything, all our insurance. What do we have in our insurance columns? Let's take a look. Okay, so everything, all these are my X's. My X's except fraud report, except this one. That is X. The Y is the fraud. So we are identifying X and Y. You guys feel free to stop me if you are struggling with anything. So we're done with this. Now we are going to split. We are going to split into 20% and 80%. And now we have a split. We're done with this. Okay. And machine learning, there is something called dummy classifier or dummy model. So dummy model is, we already have it, it's 70%. Yeah, it's 70%. So simply, if you were to guess on 0, it's going to be 70%. If you were to guess on 1, it's going to be 25%. Parvati called. If I were to guess if it's 1, it's going to be 25%. She is 1. If I were to guess 0, it's 75%. So if I were to guess if she's lying, yeah, I would say to the management, she is 25% lying, but I'm 75%. I could be wrong. And if I were to do the opposite, I could tell the business, she is 75% telling the truth, but I could be 25% wrong. So let's use machine learning to predict that. And we are going to import from a scikit-learn is the library we are going to use. It's called scikit-learn. Scikit-learn. Yes, scikit-learn.org. And the scikit-learn, it does support classification where you have a target variable that is a binary, trinary, multi-class nominal. It does support regression when you have a target variable that is continuous. It does support clustering when you don't have a target variable. And also it's used for dimensionality reduction. It's used for modeling. It's used for preprocessing. Preprocessing, we're talking about missing values, outliers, anything that you need to do in regards of fixing the quality of your data. Okay, so now we are gonna import. It's called dummy classifier. And we are going to guess using the most frequent. What is the most frequent Parvati? What is our most frequent?
Most frequent?
Yes.
Is the legitimate?
Yeah, is legitimate, right? Most frequent is. Yep. So we are going to make a guess using the most frequent. Here we go. And now we are going to calculate the accuracy. So all zeros, and the accuracy is going to be 75%. So in other words, any model that we are planning to design, or we are building, we are utilizing, we are using, it has to beat the 75%. Otherwise, I don't need you. I'm going to simply fire you and use my guessing. So I'm hiring you. I'm paying a lot of money. I want you to improve the accuracy of my guessing. I'm tired of guessing. Now I need a better accuracy. Okay. So now we are going to import from scikit-learn. We are going to import decision tree, and we'll talk about decision tree shortly. So we are going to import the model, and decision tree is one of them. If you go to scikit-learn, click on classification. There is linear model, linear, quadratic discriminant, kernel ridge, support vector machine, stochastic gradient, nearest neighbor, Gaussian process, cross decomposition for time series, naive Bayes decision tree. So we are going to import this animal here. We are going to import decision tree. Okay, that's what we are trying to import. We are going to import from scikit import tree, and then we are going to build something like this. Okay, so let's import a decision tree. Okay, it's done very quick. And now we are going to initiate, or we are going to create. Yeah, we are going to use the modules or the classifier with simply a few parameters. We are going to initiate the model. Then we are going to use the initiated model with the fit, and we are going to test it on 80%. 80%, this is X, this is Y. Are you guys following me? Yes, no, maybe.
Yes.
Everybody, are we guys in the same page? Imran, Haina, Fauzia, Carolina, Azam, are we at the same page, please?
Yes, brother.
Okay, good. So we are gonna fit. We are gonna use the fit function. Yeah, we established the connection. Yeah, this is how we did it. And now we are gonna train the model 80%. This is our 80%. It's done. It's done in 12.9 milliseconds. Very fast. So what happened is we learned something. We learned a mathematical function. How good this mathematical function is, we are going to test it on the 20%. 20%, we are going to test it. So when we split the data, into two parts. There we go. We split our X and Y into training features and target features, and testing features and target features. So this is 80%, this is 20%, and this 80%, we got X, comma, Y. The X is training features, the Y is the target feature. You could name it whatever you want. It's simply my names. And the 20%, we got also X and Y. So the X is test features, and the Y is target variable, and we split into 0.2 and of course 0.8. So we are going to feed the model on 80% training features and testing training target, and we are going to predict on only testing feature, and the model is going to create something that we compare to. Okay, so now we imported we imported the library, the model from scikit-learn. We initiated the model. We feed the model on 80%. Now we are going to test the model on 20%. And whatever we found is going to be stored in this variable called DT decision tree pred. And the value of this decision tree pred is going to be zeros and ones. So this is our prediction, and this is our true target variable, actual target variable. So now we need to compare this is the y hat or predicted target variable to the actual target variable. To make prediction, we are going to import from scikit-learn some measurement. We are going to import accuracy, classification error, and confusion matrix. We are going to use now confusion matrix. Confusion matrix is a cross table. Confusion matrix is a cross table that we are comparing test target. What is test target? Can anyone tell
20%.
me? What is test target?
Why?
Y
20%.
hat.
Why what? Yes, brother, you are in the right direction. Shahid?
Y hat.
No, sir.
So y variable we have, we're looking into the result of that.
Where is this y variable? Where?
In the that's something we are finding.
20% of the sample.
No, you guys get a little bit confused.
Okay.
So what is? Take a look into this chart. What is the test target?
$20.
Say again.
20%.
No, ma'am. You are very close, Noreen. Noreen, Zafar, you are very close.
25%.
No, ma'am. So test target.
And Y.
So what do we have here? 80% we got X and Y.
Yeah.
And the 20% we got X and Y. What is
X
test
and
target?
Y.
Test target is 10%.
No, ma'am. The test target is the Y of the 20%.
Yeah.
Is the Y.
Yeah, that is correct.
Why? Yeah, sorry.
Okay? And we are comparing it to what? What is TD pred?
Decision tree.
No, ma'am. Can anyone please help?
We comparing with the actual data we have, the 20%
To
of
the
it.
80% test data.
Yeah, this is the actual data that we have.
Yes.
Yes, this is actual data. We are comparing it to what?
To 80% of the X?
Of the test.
To the calculated prediction, actually.
Target variable.
What is this? What is this?
This is the calculated prediction, right?
Yeah, can anyone explain cell number 19? What are we doing here?
Decision tree.
No, ma'am.
We are using the X, the 80%
No,
to
ma'am.
make that prediction. No?
No.
Prediction.
What is test underscore features?
Features.
Those are the X, right? X for the one.
X1.
Sure, that is
X1.
X of what?
So that's a prediction. X of the test data.
Which is 20%.
Right.
So we built a model on X and Y of 80%. X and Y of 20%. Of 80%. So we built a model on 80% X and Y. Okay, and now we are going to take this model and we want to see how good it is or how bad it is by simply testing it on 20%. So when we build the model, we use the fit function. Fit means train. We train the model on 80%. X and Y. The X of the 80% is called training features. The Y of 80% is called what?
Testing features.
Prediction.
No, ma'am.
Target variable.
No, ma'am. Just use the terminology that we are using here. In cell number 18, we are training a model on 80% X and Y. The X of 80% is called training underscore features. That's why we named it. And the Y is called what?
Training underscore target.
Training underscore target. Please follow up with me, otherwise you are going to be confused and you won't be able to get the picture. So this is X, this is the Y. So we build a model on this X and Y, just we are giving them different names. So we learned something. And now we are going to test that something on what? On 20%, right?
That's correct. Yep.
And we are not going to give all the data to this model. We are going to hide something. What are we hiding from the model?
The Y.
We are going to hide the Y. And what is the Y? What do we call the Y?
It's a test target.
It's called test target. So what we are going to give to the model?
Test feature.
We are going to give it test features, and we are going to
Which
hide.
is the X.
Yes, X, and this is the Y. We are going to hide the Y, which is in our case test target. So this is what we did. The first we use the feed, the second we are going to predict. So this model is going to do what? It's going to create its own target variable. It's called predicted target variable, or Y hat. And now we are going to compare two things. We are going to compare the actual Y of the 20%, and that is a target feature, and to the predicted target variable. Using what? Using confusion matrix. So we are comparing the test target, which is, what is test target again?
Y.
Of what?
Y.
20%.
Yes, this is the Y of 20%. And the DT pred, what is the DT pred?
Think
Y
like
hat.
we assign to something here. To the test Y, test X.
DT
Decision
pred
tree prediction.
is
the predicting model.
Is the prediction. So we are going to compare.
X.
Import first, then we are going to compare. So please follow up with me. In the 100% our data, in the 100% data, how many zeros that we have and how many zeros that ones that we have? 100% means in 1,000 claims that we have.
75% or less.
700 and something.
Yes, guys, and I mean, you know it, So you got 75%, it's 1, and 25%.
And 25% set to 0.
I think it's other way, right? 75% is 0, which is less than 8.
No, just wait.
It can be.
So we split this data into 80% and 20%. Okay, of course, in 80% we are going to have zeros and ones, right?
That's correct.
And in 20% we are going to have what and what?
Both.
We are going to have some cases they are zeros and some cases they are zero.
We have zeros.
So how many features that we have? How many row records that we have in total?
1,000.
1,000.
1,000. Yep.
And when we split, how many we have in 80%?
800.
700 something.
800 and 200.
200.
Okay. So now we are comparing. We are comparing the x of 20% with the prediction of 20%. So in total, we need to see we have a table that looks like this. So this is actual. In the actual, what type of claims that we have in the actual? How many types of target variables, or how many types of claims that we have in the 20%?
2 types.
What are they?
Legitimate and
In terms of binary, you tell me in binary.
0 and 1.
0 and 1.
0. Mm-hmm.
When we predict what we are going to get in prediction, we could get something. What would be the possible prediction?
Either 1, 0 or 1.
0 or 1.
Or 1.
So this is actual. We got 0 and 1, and this is prediction. We got 0 and 1. So this is zeros, and this is ones. So in this confusion matrix, we got 125, we got 26, we got 17, we got 32. Someone who is good in numbers, how many zeros that we have and how many ones that we have? Someone who is good we got here 949. Should be
151.
151. Here we go. And the total, how many we have?
200.
Okay. So 125, they were 0. And the model predicted them as 0. Is this good or bad?
Good.
That is good.
And 26, they were 0, but the model predicted them as 1. Is this good or bad?
Bad.
Okay. We got 17. They were actually 1, but the model predicted them as 0. Is this good or bad?
Bad.
And the model 32, they were actually 1s, and the model predicted them as 1. Is this good or bad?
Good.
Now the question, how many good predictions and how many bad predictions in total? Out
157 are good.
of 200 records that we have, the model made how many errors the model made?
57.
It's good.
43 errors.
43.
How did you come up with 43, please?
So the
The
good
ones
here is like 125 plus 32 are good, which is 157. Out of 200, the remaining would be the error rate.
No, you just tell me. Let's make it. Let's break it.
26 plus 17.
No. 43. How did you come up with 43?
26 plus 17.
7 minus 200, which is the
Plus 17. What is 26? Is the error the model made and the zeros on the legitimate, and the 17 is the error the model made on fraudulent.
Yep.
And 157, where did they come up with this number? We got 125 correct prediction we made in the zeros plus 30.
32.
So now we are going to calculate the accuracy. The accuracy, it is going to be the accuracy of the model. It is going to be all good prediction divided by everything. So you tell me, what are good predictions? We got 125.
157.
157.
Divide by what?
200.
26 plus 17.
But I have a question there because it seems that.
You just hold on, ma'am. Just hold on. I promise. I'll let you ask your question. Let's calculate the accuracy and 78.50.
Yeah.
So what do we need to do with this 78.50? What do we need to compare it to make sure if it's good or bad?
To the original accuracy we had, 75% something.
It does not call accuracy, right? It's called guessing.
Okay.
So we need to compare it with the original guessing, which is 75.5. So 75.5. If we were to guess, I could say, Parvati's case, she is lying 25%, but she's telling the truth 75%. If I were to use a model, an algorithm to learn patterns and go through all that scenarios, the model here is telling me that Parvati is 78% accurate and probably 79 and 11 is lying. Is this
21?
21 is like error.
I'm sorry, 21. Yeah, sorry, ma'am. 21 is this good or bad?
Better. It's a better model.
I mean, it's better than guessing, but it's not. It's not
a good one, but it is better as compared to a guessing.
That is machine learning. Very, very simple. Okay, I know. Carolina, you had a question.
Yeah, well, we give a parameters of 80 and 20, and it seems that when we run the prediction, that's very close to what we got. We got like 21% of the 43 errors, and the difference, it was the accuracy, which was 78%. So I don't know if there is any particular correlation right there, because we are already kind of giving those parameters of 80 and 20, or maybe I'm clearly not seeing what the model is doing.
I did not get your question.
I know. We have these parameters for 80 and 20, right? We are testing the 200 records.
They are not parameters.
Okay. What are they? I'm sorry.
That is a data. You have two data sets. One is 80% and one is 20%.
Okay, I see.
They are not parameters. They are actual data.
Okay, and out of the actual data based on those percentages for each set, we get a very similar result when we apply the model. We have 22% pretty much out of the failure and 78 of the success out of the 200 records. Is there any particular correlation to that? It was just a coincidence that it was so close into the percentages of the data that we feed in the model?
No. I mean, you're talking about we split the data in 80%, 20%, and we got the accuracy 78%. No, there's no correlation. Is that what you're talking? Okay. Is this why you're trying to?
Yeah, that's kind of what I'm looking into. Yeah, because it's fairly close and it has nothing to do. Okay.
Totally two different animals. Sorry, ma'am, for not able to comprehend your question.
No. I guess the question is, yeah, I understand now. Thank you, Mom.
You're welcome. So, so the model makes two errors. Please pay attention. This is very, 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 very important. And I'm going to ask you a very simple question, and I hope you'll be able to. Okay, so the model made two errors. The model made an error on the zeros. The model made errors on legitimate claims, and the model made errors on fraudulent claims. You guys agree?
Yes.
Which one of these two errors are very expensive?
The fraudulent one?
Is it the 17 or the 26?
26.
Anyone?
17. 17.
17.
Why?
It's fraudulent. You're paying it out.
Let me give you an example. Okay, and we have male and female here. Female, she felt like she is pregnant. She went to her doctor. Yeah. So the female, yeah, this is female. She's actually pregnant, and she could be fat. She could be pregnant, right? You guys agree?
Yeah.
The doctor said, "Hey, I mean, you are pregnant. You're actually pregnant, but the doctor told you, hey, don't worry, you are only fat." Then what do you think you are gonna do? You are gonna go take your vacation,
Go to an
the beach,
second doctor.
Play soccer.
fly soccer, do whatever.
Yeah, yeah.
Okay. And if you are fat and the doctor told you are pregnant, what do you think you are gonna do?
Gonna be very careful.
No, yes,
Like,
and you are gonna go to
just taking care of whatever needs to be like
how
for
much
the
money you
health.
are going to spend? How much money you give me those sisters who were pregnant in the past? How much money you spent in the first 4 or 5 months?
I think at least like $300 a month.
Yeah, just let's make it 1,000.
Yeah. So
For this one, it is going to be 1,000, and this one is going to be. What do you think? I mean, for this one, we are going to lose $1,000. How about this one? You are
more.
pregnant. You are pregnant, but the doctor says, let's
You're
switch it.
fat.
For this one, you are fat, not pregnant. This one, you are pregnant. And the doctor says, hey, don't worry. I mean, this one, it says you are pregnant. And of course, you are going to call your husband, your spouse, hey, I'm pregnant, we're expecting a baby. Then you start shopping, you start inviting the family, telling your family, and everybody was expecting the new baby within 6-8 months. So you are going to spend some money in there. You are going to prepare for your vacation. You are going to take a break from work. And towards the end, the 9th month, you find out your doctor lied to you. Right? What did we lose?
Mhm.
Money?
Oh, money.
Money, yes. We lost money. It could be 1,000, it could be 20,000. Who cares? But it's money.
Mhm.
For this one, you are pregnant. But the doctor said, honey, whatever he calls you, don't worry, you are not pregnant. You are simply fat. Then no, of course, you are gonna change your daily activities. You'll be playing soccer, as someone said. You'll be traveling on a cruise. Imagine that you were traveling in Moroccan desert, in a rally. Then all of a sudden you feel this is your time. You know what's going to happen?
Rushing to emergency.
You could die. You could.
Yeah.
There is no emergency. Unfortunately, there is no emergency. You are nowhere in a desert. Emergency is going to come 16 hours later. If you have a phone with you, if you have a phone with you. No, you are in a desert, nowhere, enjoying your life. You believed your stupid doctor, your stupid algorithm, and you are not prepared. And what's going to happen? It's not dollar anymore. It is going to be life.
Life. It's a life.
Disaster.
It's not only one life. It could be you,
life.
the baby, the family. You are going to ruin everything. So which one is more expensive?
The second one. The life is more expensive.
So this one, this one is negative. And the 0 is called negative. This one positive. This one negative. This one positive.
It's a false negative and false.
Yes, ma'am. That's what I'm trying to say. So if it was negative and the model predicted as negative, is called true negative. If it was negative, in the actual is negative, and the model predicted as positive is called, this is not positive. It's actually
It's a
negative.
false positive.
It's false positive. And if it's positive and the model predicted is negative, it's
False negative.
False negative.
and this one is true positive. So which one is more expensive? Is it false positive versus false negative? False negative is very, very
False negative.
And if you want to build a model, and always you need to watch. So if you are building many models, watch the accuracy, at the same time watch how many errors it does for false negative. I really hope this is not confusing for most of you guys. Since you are quiet, I don't know why you feel, but the model is giving us 87. Can we improve it? Yes. So now let's take a look into the actual. We are going to look into the actual decision tree, and I promise to talk about decision tree later, since we are running out of time. Okay, Psyche Learning Turn 6. Oh my God! So I need to. I'm going to run this very quick. I'm not going to explain this. Let's import this animal. Install. Why is that? Let's Google this. What could Safir please mute yourself? Safir?
Yeah, I'm sorry.
Thank you, sir. And Carolina, please mute yourself as well. Thank you, guys. So yeah, we start with our base model is 75%. Okay, our base model is 75%. Where is it? Somewhere, 75%. And our decision tree model is 78. It's better, but it's not that better. What do you think would be wrong? What could be wrong with this learning? Please go back to the analogy of a child and the candle, and the red toy and the gas burner. Just go to that mental picture. Yeah, you are gonna have there's an answer.
You failed to get the patterns very well.
Yeah, failed to get the patterns. Why is that? When the child failed to when do you think a child or the baby is gonna touch the burner, the gas burner again?
I mean, if he's only memorizing the objects.
Yes, ma'am. So, and this is what's happening with this data. So this data here, the decision tree is memorizing the data. So now we got every element of our data in this decision tree. So it's called overfitting. So we need to prune this tree. We need to cut this tree somewhere. We need to stop it somewhere. And to stop it, if I stop it, I mean the accuracy is going to increase dramatically. So we don't want decision tree to learn all the way to the end. So we are going to do max depth. So we are going to build one split, second split, third split, and we are going to stop. Let's do that. So we are, and I will talk about this. I have not explained decision tree yet, but I promise to explain it later in the next model or next session. So max depth is 4. Okay, now we are going to train the model. We are going to predict. We are going to compare. Now we got 1726. What do we have?
825.
No, that is not
625.
625.
Yeah.
Now let's do the accuracy. It's 84. It's way better. And now let's take a look into the tree. It's pruned. It's now learning. It has learned something rather than memorizing something. And now we have a better guard target variable. So when let's say Parvati calls in, so Parvati, she's just calling, and I'm going to ask you, Parvati, can you tell me what is the severity of the accident? Is it below 0.5 or you say it's above? Now I'm going to ask you, what is your hobby? And you are going to tell me it's chess. Then I'm going to ask you, what is your state? So we are going this direction. If you say
North Carolina.
then I'm going to tell you are lying. I think we got 0, 0. So you got 0. You got 9. You are lying. Okay. Then I ask you again. Someone's just called in. We are going to ask them, what is your the severity? It's less than 0.5. Yes. Then what is the total loss? Is it greater or 0.5? It's less. Now, what is your vehicle claim? What is your hobby? Then you are lying. So this is a tree. Simply when someone calls, we are going to ask questions. What is this? If it doesn't meet the trigger, we are going to go both directions, either left or right, and we keep going. And at the end, we are going to have a 0, 1, or 0 or 1. So we started with the guessing, which is 75% accuracy, and now we got 84%. And we improved from guessing and to 85%. So before it's 25%, we could be wrong. This one is 15%, we could be wrong. It's way much better than the guessing. And I'm going to stop here, guys. No classes next weekend because of the end of Ramadan. I'll see you guys on the following week. Until then, you guys have a great evening, and assalamu alaikum wa rahmatullah.
Okay. Advance Eid Mubarak.
Thank you.
Thank you.
Thank you very much.
Bye, everybody.
Mo, I have a question.
Too late, brother.
Okay.
Yeah, go ahead.
Only one question.
Yeah,
One
go
question.
Go ahead.
Okay, so this is Iran, they have increased this accuracy. If you am trying again run, it will improve or it will be the less.
It's always going to be this very close.
Okay.
Yeah, it's not. It could be 84.7, 84.9, 84, something around that.
Okay. Thanks.
You're welcome. And so next session, we are going to talk about what is actually a decision tree, how this decision tree is making decisions. We know that it's making decisions based on information-based learning. We want to go through that. And next, the following week, we are going to have, we'll talk about decision tree, and we are going to learn another model. So we are going to build as many models as possible. Of course, we are not going to build all models. Yeah, we are going to simply build few models. And we are going to build let's see what we could build. So we are going to build decision tree. We could build naive based on logistical regression, and that's it. At least I'm trying to help you understand how this machine learning are working. Okay, folks. Assalamu alaikum wa rahmatullah.
Wa alaikum assalam wa rahmatullah.
Thanks, Mo.
You're welcome.